Now, this is a tricky little multiple choice question. If you're an experienced statistics teacher, your mind will probably go right to the fact that it says at the 5% significance level, the appropriate decision is a type 1 error. And the statistics teacher may be like, did he make a mistake? Because really, most of the time when you have these multiple choice questions, you say could be a type 1 error. So did this guy make a mistake? Well, no. I'm phrasing this. Now, we're getting into some tough questions here, but I phrased this consciously knowing, what I was writing here. So with the 50% p-value, actually at both of these significance levels, but let's just look at the 5% first. The appropriate decision is to fail to reject the null hypothesis. Why? Because this p-value is not less than or equal to this significance level. So that makes a type 2 error possible, not guaranteed, of course, but possible. But what it also does is it makes a type 1 error impossible with 100% certainty. Think about it. When you fail to reject the null hypothesis, see over here, you only commit type 1 errors when you reject the null hypothesis. So with absolute certainty, we can rule out type 1 errors and say they are both impossible, making both of these propositions false. So the correct answer to this slightly tricky multiple choice question is D. Now, of course, I'm going somewhere with this. Let us now look at question number 2. Same exact question. 50% p-value. Let's look at the 5% significance level. This is a tricky little question. Here's why. At the 5% significance level, the appropriate decision is to fail to reject the null hypothesis because this p-value is not less than or equal to this significance level. So when we fail to reject the null hypothesis, that makes a type 2 error possible. Oh yes, a type 2 error is certainly possible, but the word is suggests that it's guaranteed. Now think about how stupid it would be to study statistics and to spend money on a stats class and to even conduct studies and pay money to use statistical analyses if you were guaranteed to make a type 2 error 100% of the time. If you were guaranteed to make an error, then statistics would be the dumbest subject that I could possibly imagine spending money to study. So, of course, the appropriate decision is to fail to reject the null hypothesis, and a type 2 error is possible. Now, look at the definition of type 2 error. It says a type 2 error is failing to reject the null when the alternative is true. So if the human being knew that the alternative hypothesis was true, then the human being would know that the appropriate decision is, in fact, a type 2 error. But the human being would not perform a statistical hypothesis test if the human being knew which hypothesis was true. What a waste of time and money that would be. So, since we don't know which hypothesis is true, the best the human being could say is that this proposition is either true or false. It'll be true if the alternative hypothesis was true. We wouldn't know that. And it would be false if the null hypothesis was true, because that would be a correct decision, right? If the null hypothesis was true in this case, then the human being would make a correct decision, which of course is what we want to do as much as we possibly can. So it is not possible to determine the truth value of this proposition. It's what we in mathematics call an indeterminate truth value. And so there are no choices here with indeterminate truth values. And so this tricky little multiple choice question has an answer of E, none of the above.